Salam everybody, so welcome to the Kinematics worksheet. Let's start these three questions. In the following list, underline all quantities that are SI based quantities. You know that there's a difference between quantity and unit, and you should have a very clear idea that charge is not a unit, it is a quantity, but it's not a base quantity. Electric current is a base quantity. Force is not a base quantity. Time is a base quantity. If they asked you for base units, you would say seconds and amperes. The conditions for the equations of motion. So this equation is actually S is equals to ut plus half at square. And we can clearly see that ut is not there, which means that this is 0, which means that my initial speed is 0. Or you can even say that the body is at rest initially. And the second thing is they've already mentioned that you're moving in a straight line. So the other condition for the equation of motion is that your acceleration is constant or uniform. So there are two primary conditions. Number one, it should be straight line motion or linear motion. Second, acceleration should be constant or uniform. And the third, which I wrote, which is the initial speed is 0, that comes from looking at the equation because you can't see ut, so you can assume that the initial speed is 0. Part C, the variation with time of the velocity of the car is shown, and this is moving in a straight line. Now you must understand, what is this graph showing? So this is a velocity time graph, and you can see over here that the velocities are negative all the way till 4 seconds, and at 4 seconds the velocity becomes positive. That means that at 4 seconds your direction changed. Try to understand that you were moving in a straight line, so maybe you were moving like this. Then at 4 seconds, you started to move in the opposite direction, which is why the velocity sign also changed. And if you're wondering why is it negative, it is because whenever you have a vector quantity, Javanos, you have to assume one direction as positive. So maybe this direction was assumed to be negative. So when you were moving in this direction, like this, you had an initial speed of minus 10. Then you had a speed of minus 5, and then you had a speed of, if you look at this blue dot, then you had a speed of 0. That is when you stopped. And then you reverse direction. Now think about it. When you reverse direction, you're moving in this direction. You've taken the right direction to be negative. So what will this direction be? Positive. And that is why the velocity then starts to increase to 5, to 10, to 15, to 20. Do you understand? So this sign change shows that the direction changed. And whenever you change direction, remember that your velocity has to become 0. When it becomes 0, then you change direction. You have to stop and then you have to turn. That's when direction changes. So compare qualitatively. Qualitatively means without numbers. You just have to write it down. The acceleration of the car, t is equals to 8 and at t is equals to 14. Now you know that the gradient of this graph gives you acceleration because it's a velocity time graph. And can you notice one thing? Can you notice that the gradient is less steep over here and it's more steep over here? 14 seconds means this part, 8 seconds means this part. So can you see that this is steeper and this is less steep? So that means that the acceleration over here is less and the acceleration over here is more. So they ask you to compare the magnitudes. You will say that the acceleration at t is equals to 8 seconds is less than the acceleration at t is equals to 14 seconds. And what about direction? You can clearly see that one is upward sloping and one is downward sloping, which means one acceleration was positive and the other one was negative. So that means that the direction was also opposite. So the acceleration at t is equals to 8 is opposite in direction to the acceleration at t is equals to 14 seconds. Determine the magnitude of the acceleration at t is equals to 4 seconds. So if you go here, you have to tell us what is the magnitude of the acceleration. Again, it's the gradient. So, and it's a straight line, so you can literally take any point. At 4 seconds, your velocity is 0. At 0 seconds, your velocity was minus 10. So can I say my initial velocity is minus 10, my final velocity is 0, and the time that went by in this journey or in this process, when I moved from minus 10 to 0, how much time went by? 4 seconds. You could do it by acceleration formula, or you could do it by gradient. I'm going to do it from acceleration's formula, which is A is equals to V minus U over T. Final speed is 0, initial speed is minus 10, and the time it took me was 4 seconds. So this is going to be 10 divided by 4. Now you can just move this and you can write it down over here that your acceleration will be V minus U over T. Final speed is 0, initial speed is minus 10, and the time was 4 seconds. So this is going to be 2.5 meter per second square. Now, the car is at point X at t is equal to 0. Determine the magnitude of the displacement of the car at t is equals to 12 seconds. If you go back, t is equal to 12 seconds is this point, and they're asking you for the displacement. Displacement is the shortest distance between the start and the end point. So if you look at the example that I gave you over here, first you were moving right, then you start moving left. What is your displacement? Displacement is the shortest distance between your start point and your end point. So this, not this actually, your if you're moving in a straight line, so that means that you move like this, and then you came back on that line and you move like this. So what is your displacement? Your displacement will be from this start point to this end point. So this is your displacement. Do you understand? So you started from here. I'll put my finger here. You went here, and then you went there. Now, if they ask you what is your displacement, that means they're only asking you to calculate what is this distance, the shortest distance. If they asked you to calculate what is the total distance, in that case, you would have to calculate this, and you will have to add all of it. In displacement, you will calculate this distance, then you will calculate this distance, but I just wanted this one. I just wanted this piece. Itna sa. So what do? I subtract. Do you understand? Because you're moving right and then you're moving left. What is your displacement? Just subtract the two things because you're moving in opposite directions. So calculate the two distances. Calculate this area under the graph. Because in this, you were moving right, for example. So this area under the graph is going to be half into base into height. So half into 4 into 10. So this is going to be 2 and this is going to be 20 meters. And then you calculate this area under the graph. Because this is when you change direction. So you move 20 meters to the right, for example. And now you are going to move half into base into height. So 1/2 of base, which is going to be 4 minus 12 or 12 minus 4, which is 8 into height. This is 20. So into 20. So this is going to be, this is 10, 8 into 10, this is 80 meters. So you moved 20 meters to the right and then you moved 80 meters to the left. Now you tell me. So if you move 20 meters to the right, you stop. You change direction and you move 80 meters to the left. What is your displacement? Your displacement is going to be the shortest distance between your start point and your end point, which is going to be 80 minus 20, which is 60 meters. And if they ask you what is your total distance that you've traveled, in that case, would you add 80 and 20 or would you subtract? You would add. So in this case, you can do all of the working over here now. Your final answer is going to be 60 meters because you move 20 meters one way, 80 meters the other way, and the net displacement was 60 meters. Question number 2, define momentum. Momentum is defined as the product of mass and velocity. Two balls x and y of equal diameter but different masses are respectively slide towards each other on a frictionless surface as shown in figure 2.1. Both balls have the same initial speed of 2.3, but they've got different masses before they collide with each other. And this figure 2.2 shows the variation of the force acting on y. Always remember that in all collisions, Newton's third law is obeyed, which means that the force on x should be equal to and opposite to the force on y, regardless of the masses. Alright, now they're asking you to calculate the kinetic energy of the ball before the collision, ball x before the collision. So what is the formula for kinetic energy? The formula for kinetic energy is half mv square. Now you have the mass, which is 0.24, and you have the speed, which is 2.3, so half into 0.24, half into 0.24 into 2.3 square, and the answer that you get is 0.63 joules. There's something missing over here, but I'm going to write the unit, 0.63 joules. Next, the area enclosed by the lines in the time axis represents the change in momentum. You should know this. The area under the graph, you're given force on the y-axis and you're given time on the x-axis. The area under the graph represents the change in momentum. Why? Because area under the graph is rise into run. On the rise axis, we've got force. On axis, we've got time. What is force and time? Force and time is the change in momentum. So they're asking you to calculate what is the change in momentum of ball y. So just calculate the area under the graph. This is a triangle, so you're going to do half into base into height. This is representing the change in momentum. So half into base. Now you look at the base, it's 5, but it's milliseconds. So 5 into 10 raised to power minus 3 into the height. Look at the height over here. That's 200, 220, 240, 260, 280, 300, 320, 340, 363. Yeah. So the graduations, one small line is 20. So this is 240. So into 240. And you can again do this in the calculator. Half into 5 into 10 minus 3 into 240. And you get half into 5 into 10 is minus 3 into 240. And you get 0.6 Newton seconds. 0.6 Newton seconds. All right. Calculate the magnitude of the velocity of ball y after the collision. Now, you've calculated the change in momentum, right? Change in momentum is mv minus mu. Correct? The change in momentum is 0.6. So 0.6 would be equal to the mass into the final velocity minus the mass into the initial velocity. Now, do we have the mass and the initial velocity? We do have the mass and we do have the initial velocity, which is 2.3. Now, bear this in mind. If you're taking, again, you have to assume a direction because you're dealing with vectors. Let's assume this direction to be positive, for example. Then this is going to be negative. So I'm going to take over here mv minus mu. I don't know what is mv, so I'm going to leave it like that. My mass was 0.12. So I'm going to write 0.12 into my initial velocity was minus 2.3. Minus 2.3. So 0.6 is equals to mv minus, and minus will become plus, and 0.12 into 2.3 gives me 0.28. So mv turns out to be 0.6 minus 0.28, which is 0.32. Now divide this by the mass, which was 0.12, to calculate what is the final velocity. 0.32 divided by 0.12. The final answer that I'm getting is 2.67. 2.67. And do you realize that your final answer is positive? Why? Because it shows that after this collision happened, y after the collision was moving this way. How do I know? I know this because my answer has turned out to be positive. If my answer was negative, my answer has turned out to be if my answer was negative, then that means that if I was coming from here and this direction is negative, and after collision I'm still getting a negative answer, that means that I was still moving in this direction. But that's not the case. I was moving in this direction and I took this direction to be negative, as you can see over here. I'm taking 2.3 to be negative, so which means I'm taking the direction of y to be negative. And then I get my final velocity as positive from the equation. What does that mean? That after collision, y reversed direction. So 2.67 should be the final answer. Now, part C. On figure 2.3, sketch the variation with time of the force X exerted on the ball by ball Y during the collision. I just told you about Newton's third law, and I told you that the force in a collision will always obey Newton's third law. So the forces have to be equal and they have to be opposite regardless of mass. So it's going to be a triangle, and it's going to be a triangle in the downward direction, and the forces have to be equal. So minus 200, minus 220. Alright, part C. The ball is in contact with the ground for a time of 0.091 seconds. The ball rebounds with a velocity of 5.4. Dekho, look, the ball is in contact with the ground for a certain amount of time. Now, when you hit the ground, what was your speed? Your speed was 8.7. There's a lot of vectors in this question. When you rebounded, which means you went back up, your speed became 5.4. I always tell you velocity is a vector quantity. Whenever you're dealing with any vector quantity, what do? You change the sign if the direction changes. Because if downward direction is positive, upward direction cannot be positive, it has to be negative. So whenever direction changes, remember this in your exams, you have to change the sign. So it's up to you. You take this as plus and you take this as minus. That's completely your call. Or you take 5.4 as plus and 8.7 as minus. Completely your call. But you have to change the sign because the answer will change if you do not take the sign into account, and that will be the wrong answer. So force, the change in momentum will be mv minus mu. Your mass is 0.059, as they've said. Your final velocity is minus 5.4. Now, this is the negative sign of the formula, so that comes as it is. Minus 0.059 into the initial velocity, which is plus 8.7. And you solve this, and you can actually take 0.059 common, and you will get minus 5.4 minus 8.7, because this plus and this minus will multiply, will give you minus. So let's do it in the calculator. That's 8.7 and 5.4 times 0.059. The answer that I'm getting is minus 0.83. So you can write that as minus 0.83. And because they're only asking, look at the question, they're only asking for the magnitude of the change, you can absolutely ignore, you should ignore the negative sign. Why have they asked you for the magnitude? Because there could be kids who would take this direction as plus and this direction as minus, because they haven't mentioned which direction is positive and which direction is negative. But if you don't do this and you simply take 8.7 and 5.4 and you plug them here, you're not going to get the right answer. So just remember that taking the right direction as positive and negative, either one of them is important. You can't do your question, any vector question, without that. Now, what is the magnitude of the average resultant force? So average resultant force is rate of change of momentum. So the change in momentum is 0.83, and the time that it took you was 0.091. Divide 0.83 divided by 0.091, and the answer that you get is 9.14 newtons. You can write that as 9.1 newtons. Use your answer in C2 to calculate the magnitude of the average force exerted by the ground on the ball. Now you know the forces are equal and opposite. The first question is, when your ball strike the ground, how much force did it exert on the ground? Two forces, not one. One was the force due to the collision, due to the speed. That was one force. And the other one was the weight of the ball. That is also going to impact on the ground. So the force, the total force acting on the ground is this. So as a result, when they're asking you what is the average force exerted by the ground on the ball, they're asking you for this force. What is the force exerted by the ground on the ball? You're going to say it is going to be the same as F and W, which is 9.1 newtons, and the weight of the object. What was the weight? We don't have the weight, we have the mass, which is 0.059. So I'm going to do 0.059 times 9.81. So 0.059 times 9.81 plus 9.1. I'm getting 9.67 newtons. So 9.7 newtons is the answer. I hope this is clear. The ball was thrown downwards at t is equal to 0 and it hits the ground at t is equal to t. Sketch a graph of the speed of the ball. Direction does not matter. And you started off with some initial speed. They've said that the numerical values are not required. You knew that air resistance was negligible, so acceleration was constant. So this is simply going to be a straight line from here to there. In practice, air resistance is not negligible. State and explain any variation, if any. You have to explain it. So I have to explain the theory as well, rather than just explaining what will happen with the graph. State and explain the variation of any of the gradient when air resistance is not negligible. So first of all, air resistance will increase as your speed increases. So your acceleration will decrease, and because acceleration will decrease, hence the graph will be a curve with decreasing gradient, because you know that the gradient of this graph gives acceleration, and you're admitting the fact that the acceleration will decrease. That means that the gradient will decrease. And what does gradient decrease look like? It looks like this. Speed to the बढ़ना ही है. When you're falling, your speed has to increase. When you're falling, your speed has to increase. So if I'm sketching it for the same scenario, my speed is increasing because I'm falling, but my acceleration is decreasing because air resistance is going up. So the gradient of the graph will decrease. And that's it.